In this video, we're going to be doing a Unit 8 MCQ practice. So, a block is fully submerged in water at depth h1. It is then lowered to a deeper depth h2. What happens to the buoyant force? So, it's going to stay the same. So, people think that pressure increases with depth, so that means that buoyant force will increase. However, the formula for buoyant force is equal to rho fluid, the density of your fluid, times the volume that was displaced, times your gravitational constant. So in this scenario, we know that our density is going to be constant. Also, the volume that is displaced is constant. Therefore, we know that FB is going to be constant because our G is also going to be constant. It's 9.8 meters per second squared. So people would usually confuse pressure with depth. With net force difference. Again, pressure is going to change with depth, but net force difference depends on the volume that is displaced. A block floats in water with half its volume submerged. What is the density of the block? So our answer is going to be 500 kilograms over meters cubed. The reason is because you can use the ratio V sub over V is equal to the density of the object over the density of the fluid. So we know that this ratio is going to be 0.5, and we know that we can write 1,000 for our fluid, which is water. Density of the fluid is going to be 1,000, and we can write that over object. So if we multiply both sides by 1,000, you get that the density of your object is equal to 500. So that's how you get A. A block weighs 50 newtons in air and 30 newtons when it's submerged in water. What is the buoyant force? This is a question that asks you about the apparent weight of this object. So what you do is you have your force buoyant is equal to the weight when your object is in the air minus the weight apparent. So you can just plug in your values here, and you have 50 newtons when it's in the air, and then 30 newtons when it's in the water. So therefore, the your buoyant force is 20 newtons. So a common error would be reading scale error, or your scale reading as your FB. That's not right, because your scale reading is actually your scale reading is equal, or it reads your tension, not your buoyant force. Your buoyant force you have to calculate. Two objects of equal volume are submerged in water. One is denser than the other, which experiences a greater buoyant force. So this is a question where you can mess up by confusing density and mass. So the answer here is that they're going to experience the same buoyant force. Because again, in your buoyant force formula, you have density of the fluid times volume times G. And we see we only are dependent on the fluid density and the displaced volume, and of course G, but that's going to be the same, not on object density. So in the question, we're mentioned that one object is denser than the other, but we don't care about that because it's not inside of the formula. Therefore, buoyant force isn't dependent on that variable. However, weight is equal to the mass times gravity, where you do have the mass of object, and that is dependent on what the weight, or that is dependent on the masses. So weight is not equal to buoyant force. It's not the same thing, which is why they have the same buoyant force still. So a block sinks in the water. Which of the following is true? if it sinks, that means that your weight has to overcome the force that is your buoyant force. Because let's say you have this block, and this is your cup of water, and it sinks to the bottom. And for it to do that, on your block, you're going to have an FBD where you have your buoyant force that's acting up and your weight force that's acting down. And your weight force has to overcome that buoyant force in order to pull the block down and overcome that buoyant force, which is trying to pull it up. So buoyant force does not equal weight. F is equal to B only at your floating equilibrium. But here we're talking about when it sinks, therefore our answer is going to be C. So at a given depth, your pressure is what? So you have to remember your pressure is something that is isotropic. What that means is it's going to be the same in all directions. However, you might get confused because you'd remember, like, for example, your solids have directional forces. Like normal force, but fluids, they don't, because we have pressure, and pressure is something that's isotropic. So your answer is C. It's the same in all directions. An object floats at the boundary between oil and water. Which density creates the buoyant force? So your buoyant force can be represented as your density of your first object times the volume of the first object times G plus the density of your second object plus volume of the second object times G. So what determines the buoyant force is only going to be, or it's going to be both of them, because you have to account for both of them when you are finding your buoyant force. You have to take into account for all the parts that displace in the fluid. So a container of water accelerates upward. What happens to the buoyant force? Your answer is increases. That's because your buoyant force is already acting up. So let's say we have this container and then your object is already in it, but inside of your object, you already have a buoyant force that's trying to act up, and you always have your weight force will always act at the center of mass and it will always act downwards. But if you're now accelerating up, now you can add these two vectors. Like you see this FB vector and your A vector, your FB and your acceleration vector point up, so you add them together so they increase. So G effective also is equal to the gravity, the gravitational constant, plus the acceleration that you are experiencing. So when you have FB, you're going to have your density times your volume times not just G, you're going to have G plus A. So it's actually going to increase your FB. Now, an object floats. Which of the following must be true? When you have floating, that means your buoyant force is equal to your weight, which is equal to mg. And the portion that is submerged, your submerged fraction, depends on the density ratio. So your answer is C.